So, 90% of all the data in the world was created 2 years ago. So Onassis, what's your point? What does that even mean? Well, let's do an exercise right now. I want everybody to count from 1 to 2. 1 to 3, go. Very good. By the time as you finish counting from 1 to 2, you know what happens? Google would have already had 40,000 searches, Facebook would have already created 5 profiles, Snapchat would have already shared 30,000 photos, and YouTube users would have already watched 60,000 videos. We have an influx of data. But what is mankind's response to that? Well, the answer is data science. Data science is a field that is comprised of diverse disciplines from computer science and software engineering to probability and statistics to economic and finance. Depending on what complex issue it is you're trying to solve, you would then use that specific discipline to answer that specific question. And so my thesis is around this particular area. At the end of each day for 12 days, the efficiency of 32 machines were recorded. Using numerical methods or any other technique that I may find useful, approximate the values for day 13. Essentially, you have 12 days worth of data, predict day 13. So before we go deep into this, let's look at something for a second. What does the efficiency even mean? Efficiency values are between 0 and 100%, but in our case it's going to be between 0 and 1. 1 meaning the machine is working perfectly, 0 meaning the machine is trash. So let's take a look at the data. Warning, this is a lot of information. So as you can see, we have days as the columns and the machine as the rows with the efficiency values in between. So notice we have a lot of information here. We have the values for machine 1 for all days, for all of the days, the same with machine 2 and machine 3. So I have a question. What tools, other than mathematics, do you think is going to be needed to answer this question? Programming, period. No, I did not spell it wrong. I emphasized the T, in fact. So, period is the millennial version of saying QED, end of proof. I said what I said. I rest my case. Okay? So why do we need programming? Programming, look at all of the data that we have. We have 32 machines, and we're going to be using 3 different methods. 3 times 32 is 96. With these 96 methods that we use, we also are going to require graphs. 3 different types of graph. 96 times 3, that's 288. That's a lot of data, a lot of methods that we're going to have to be using in order to answer this question. And so, instead of using Excel, we use programming. I use Python. You can use C++ or Java, but I specifically use Python because you can get this stuff out of the way very quickly. So, what tools do we need in order to answer this question?
Period.
All right, so let's take a look at the machine now. Let's create a scatter plot. So now, I spotted a pattern. I don't know if you guys would see it, but look at machine 1 now. We're looking at machine 2. Do you see the pattern yet? What about now? Well, we have the days in the x-axis and the machine efficiency in the y. But take a look at the machine efficiency. We defined efficiency as values between 0 and 1, right? But the machine efficiency values that were recorded are between 60 and 90%. The same thing for machine 2. Machine 3 has values between 50 and 85%. So let's use some inductive reasoning here for a second and create a conjecture. So we have these values. The recorded values are within this range. So maybe we can say that the efficiency for day 13 should also be within this range. So we're going to use that, hold that thought, and we'll go to that later. We're going to introduce numerical methods in the form of interpolations. What interpolation is defined as a method used to approximate intermediate values between precise data points. What does that mean? It means that if you give me a specific set of points that I know, I can approximate what the values are in between. And so we have 2 different methods. We have, the first one is n-degree Lagrange interpolating polynomials. What that is I create a polynomial degree of order n minus 1, where n is the amount of points that I have. So I have 12 points. We're going to create a polynomial regression of order 11. So we have our Lagrange interpolation. But wait a second, Onassis, you just said that we're supposed to be interpolating values in between. That's what you said the definition of interpolation was, right? We're trying to approximate the values for day 13. 13 is not in this data set, so what do? Well, predict outside. We're going to introduce extrapolation. What extrapolation does is it uses the equation that we got from interpolation, but we plug in day 13 so that we can get the values. So these are actually the predictions that Lagrange predicted. But the graph isn't wrong. extrapolation comes with a caveat. The caveat is that you diverge. Diverge meaning you approach infinity or negative infinity when you're trying to actually get your value. So the same thing for, we extrapolate for machine 2 and machine 3 and so on. But let's see how well we did. So we have the actual values that we got from our advisor after we finished predicting everything. So machine 1 efficiency for day 13 is 0.9. What did Lagrange predict? Negative 148.6. Very close. No, we're not. This is the diverging thing that I'm talking about. This is diverging towards negative infinity for all of these values. So we don't want to use this. Let's introduce the second interpolation in the form of a cubic spline. A cubic spline is essentially the same thing as Lagrange. However, the error is minimized and the graph looks more smooth. So after we finish interpolating, we then extrapolate again now to try and find the values for day 13. Notice that we diverge again, but however, the divergence, you can get the machine, the day 13 values before we diverge to a ridiculous value. So we do all of that for all of the different machines, and we do this again. We compare it again. So the actual values for day 13 is 0.9, like we said before, it doesn't change. The spline predicted negative 0.25 too, which is better than the Lagrange, but we're still outside of that range. That's a problem. We have negative values when we're not supposed to be getting it. We may have some values that are inside of the range, but the majority of them are still negative. So what are we going to do? Well, remember that hypothesis we thought about earlier, saying that we're supposed to be using the machine efficiency values within that range, and so the predicted value should also be within that range. So we'll introduce a regression, a polynomial regression of order 3. What the polynomial regression does is you can tune the order. So instead of using a polynomial regression of order 11, which in this case I'm going to overfit, I'm going to tune it down a little bit. I'm going to tune it down to order 3. That way, my polynomial regression is going to be within this window. I don't have to worry about the values being negative. And so let's see how well we did. So we have the actual values. We know it's 0.9 for machine 1. Polynomial regression predicted 0.7. Notice that it's better than the spline, and definitely way better than the Lagrange. But not only that, take a look at all of the data points. You do not see a negative number inside. In fact, also what it also does is take a look at machine 4. Machine 4, the value is 0.7333. The polynomial regression predicted 0.7369. It does that with high accuracy for machine 5 and machine 9 and machine 11 and so on. But now, here's what we're supposed to do. We finished using all of the methods, so let's use a root mean squared error. The smaller your root mean squared error, the better your value is. So the one with the smallest is essentially the best prediction. So polynomial regression came in first at 0.136, cubic splines came in second at 0.771, and Lagrange came in dead last at 100. So before I get to that, so you send this information to your advisor. You say, okay, I predicted day 14. I predicted day 13. He said, okay, these values are pretty good. Now predict day 14. So I predict day 14 for him. And I wasn't too confident about how it was, right? But when I sent the data back to him, he said, okay, now predict day 15. Hold on, man. So I know some of you may have a question. What kind of machines are we working with anyway? And why is it so important that we find the efficiency for the next day? Well, I kind of lied to you. So essentially, my thesis was efficiency estimation using numerical methods. But what we didn't predict was machine efficiency. What we predicted was island luck. We predicted the draw 3 from island luck. So the efficiency was actually the days. So depending on after you finish playing a certain specific set of numbers that you do not change, you go ahead and you get the efficiency values from those. And so what these efficiency values are essentially is the best times for you to play a specific set of numbers for island luck draw 3. So with that being said, thank you for listening to my presentation. Do you have any questions other than what numbers to play? I can't answer that.
Yeah, I have a minor question as well.
Okay.
You showed me those first set of graphs, and you kept changing the y-axis on me. So I lost continuity with each change because you go from point 2 to 1, point 5 to point 9. So I couldn't, that distracted me immensely.
Okay. Well, I apologize. However, the y-axis was constantly changing because those were the values for different machines.
Yeah, my thing is though, as the viewer sitting down, if you kept that from 0 to 1, because that was your bound, that was your bounds anyhow, I would get a feel for how they look. Every time it changed, I'm a little closer view, I'm a little further back from the points, so I get to see more exaggeration or less.
Okay.
I was,
All right.
yeah, it's a little distracting. Maybe it's not a question also from that.
No problem. I appreciate that. Well, actually, we could have fixed the window, but I kept it right there so you can notice the different ranges within between. But like you said, it would have been better to have in between 0 and 1.
What are the implications of this region?
To win money. Well, actually, this is actually part 2 of 3 steps. So, the first project was to actually determine which numbers you're going to use. The second one, which is my thesis, was to determine the best times. Part 3, which is essentially supposed to be what I'm supposed to be doing for this entire project, but we just shortened it down because of the time, was that the fact that if you looked at the machine values, they are actually oscillating around a particular value and not following an equation. So you have the expanded mean and standard deviation being the same, meaning there's no trend, and you have homoscedasticity, not heteroscedasticity, meaning that the data isn't spread. So you can predict using time series analysis and numerical, well, not necessarily numerical methods, but recurrent neural networks, which has a smaller, an even smaller RMSE. So like how we had the values for the polynomial regression being 0.1, our RNN predicted 0.01 when you trained and 0.09 when you tested, meaning that when I was training, I was 99% accurate, and when I was testing, I was 91% accurate, and that was beautiful.
Whoa.
Can you name some of the groups in the world that are doing similar kind of thing, so that I can start the internet and see what they're doing? Like some of the groups in the world. Are you the only one doing this one, or some other groups? Do you have a literature review?
Well, we're using island luck because the ones inside of the U.S. it's a little bit difficult to approximate what the values are. So I'm not aware of any additional work outside of the US because it would be more difficult. Island Lux numbers are easily, you can find the efficiency more easily, so we use that instead.
Okay, thank you.
Thank you.
Okay, we move to our final presentation. Unless there are other presenters who did not show up earlier who's here now. Don't think so. Okay, we have our final presentation. If you see the program, you have many presenters there, so I hope you're able to manage your time. So I'm told